So an object is placed near a converging lens, a distance that is beyond the secondary focal point, as shown in this figure. So we want to draw the ray diagram to determine those three things about the image. So the first ray is the one that is drawn parallel to the axis until it hits the lens. But the first thing I want to do with this lens is just draw a dotted line right down the middle of it. So that's the point that where the lines cross it, where they're going to change direction. So the first ray starts out at the top of the object and just runs parallel to the axis until it hits that point. And then after it refracts through the lens, it passes through the primary focal point on the other side. So it's going to go down like that. The second ray, which is the F ray, that initially goes through the F prime, the secondary focal point. So we'll draw a ray like that. When it hits the lens, it refracts parallel. So it's going to go this way. And then you could draw the third one, which is through the midpoint, and that's the one that just keeps on going straight through that midpoint of the lens. So it looks kind of like this, and you can see that all three of those rays converge at that same point. So to draw the image, I'm going to extend the axis a little bit and draw the image arrow from that axis down to the point where they all cross. So that's your final image. And you can notice on this one that it is on the other side of the lens, which for lenses, when something shows up on the other side, that is real. Remember, it's the opposite of mirrors. For mirrors, when it shows up on the same side, it's real. For lenses, when it shows up on the opposite side, it's real. It's also inverted. And looking at the size of that arrow, you can see that it is larger than the original object. So now we want to do the math to kind of show it all. So the things that are given are the focal length of this lens is given as 20 centimeters, and the height of the object is 2 centimeters, and we're placing the object a distance of 30 centimeters from the lens. So in part B, to determine the image distance, 1 over di equals 1 over f minus 1 over do. So you get 1 over 20 minus 1 over 30. This is 3 over 60 minus 2 over 60, which equals 1 over 60. So take the reciprocal of that. So the image distance is 60 centimeters. That number came out to be positive, which means the image is not virtual, the image is real. So that checks out with what we have up here. For part C, the magnification is equal to negative di over do. So that's going to be negative 60 over 30. You get a magnification of negative 2, which means that the negative tells you it's inverted. So that checks out. And the fact that the number is bigger than 1 tells you that it is larger. So that checks out. And then for part D, the height of the image is equal to m times HO. So negative 2 times 2 centimeters is equal to negative 4 centimeters.